again, empirical and molecular formulas, part 2. So we're at empirical and molecular formulas, part 2. Okay, over here, I have the rules. So basically, this is the rules. Sorry, step 1, 2, 3, and 4. Okay, so write these down. They are percent to mass, mass to mole, divide by small, multiply to whole. If you can remember that, and you kind of sings with it, percent to mass, mass to mole, divide by small, multiply to whole. Then you can pretty much do any empirical formula from there. Okay, this right here is not always being used, but 1, 2, and 3 will be. But number 4 is only at certain times. So I will go ahead and do a couple of those for you, or at least do one for you, and then we'll do some more in class. Okay, so when you have empirical formulas and it's asking you what is the empirical formula of something, then what you need to know is you're going to be given percent compositions. Okay, so percents. So you have 74.1% carbon. Okay, let's say you have 8.6% hydrogen, and you have 17.3% nitrogen. Okay, so let's say you're given this in a problem and we want to know what the empirical formula is. Well, what you're going to do is you're going to take your percentages, you're going to turn them to a mass. This is the hardest step on here, guys. You're going to take these and turn them into a mass. So all you do is 74.1 grams of carbon. Real hard, right? I told you it was super, super hard. Okay, sorry, getting silly. It's really late tonight. Grams of hydrogen, and then 17.3 grams of nitrogen. Now it seems really simple, but a lot of kids won't remember this, but all you're doing is basically taking the percent sign off and putting a G on it, turning it to grams, okay? So that's step 1. So easy, right? Now we're going to take our grams to moles, mass to mole. So we're going to need to do our railroad tracks, our conversions, okay, for all 3 of these. So you're going to take 74.1 grams of carbon, okay, and you're going to go to the mass. So you have grams of carbon, 12.011. Sorry about this one. You know my board is small. And you're going to go to 1 mole of carbon. Could you make this simpler? Yes, you can. If you want to make it simple, I'm just going to do exactly what we've been doing in class. But if you figure out that this can be done a little bit easier and a little simpler for conversions, go ahead and do it. I'm not going to get my feelings hurt, okay? So then we have 8.6 grams of hydrogen divided by 1 mole of hydrogen. What's on top goes on the bottom. So we end up with 1.008 grams of hydrogen. If you're not sure where I got these numbers from, go to your periodic table. G stands for go to your periodic table, get your molar mass. Okay. Then we have 17.3 grams of nitrogen. And we're going to put it in our railroad tracks to 1 mole of nitrogen. And you're going to have right here 14.007 grams of nitrogen. What's on the top goes on the bottom. What's on the top goes on the bottom. Cross out your 1s, cross out your grams, okay? And then you multiply across, divide by the bottom. Well, we don't have anything on the top, so we're just dividing everything. When you divide this out, you're going to end up with 6.167 or 6.17. I would say go out at least 4 digits if you can, only because it gives you a better, you usually actually get better stuff that way. You can go out 3, but no less than 3, okay? 8.53 when you divide this, and when you divide this one, you get 1.24. Okay, so that is step 2. We got all of our moles. Okay. All right, moles of carbon, hydrogen, because I want you to keep doing that. Okay, so hydrogen. Okay, so that's step 2. So we percent to mass, just change them. Mass to mole, railroad tracks. Divide by small. Okay, so here, we're going to take all of these. We're going to find the smallest one. And in this case, the smallest one is 1.24. So you're going to take every single one of them and divide by the smallest. And you really don't need the moles on this, just 1.24, sorry. You don't need the moles. 1.24. Okay, so when you do the math on this one, it's very easy to get lost in here if you're not paying attention. So just sing that little song in your head, percent to mass, mass to mole, divide by small, and then if you have to, multiply to a whole. Okay, so 6.167 divided by 1.24 gives you 4.97. And here you get 6.88. And the last one, of course, is 1, because anything divided by itself is 1. Okay, so here we are having, we have to look at, because we need a whole number. Okay, so multiply to a whole. Well, if these numbers here are, you cannot have, all right, let me go back. Okay, what we're going to do is round these numbers right now. Okay, so this is going to equal 5, this is going to equal 7, and that's going to equal 1. Now, there is we didn't have to use the multiply to a whole, but when would we? Okay, when you multiply by to a whole, you will, this number that I just underlined in pink, if you have a 0.4 at the end, like you have something 0.4, or you have something 0.5, or you have something 0.6, then you multiply by 2. Okay, multiply by 2. Multiply all. Okay, can't spell tonight. I told you it's late. Multiply. Okay, I'm just going to say it. I'm not going to write it. Just write it down. Multiply all, or every one of them by 2. Every one of them by 2 to get a whole number. Okay? Now, how do we use these numbers and how do we get an empirical formula for this? Well, I have carbon, hydrogen, and nitrogen. So I'm going to take carbon. What did I get for carbon? Let me take blue. So carbon, I'm going to put a 5. Hydrogen, I'm going to put a 7. And oxygen, I'm sorry, I take that back. I'm not, like I said, it's late. Nitrogen, sorry, nitrogen gets a 1. There's your empirical formula. C5H7N1. And we don't write ones. Okay? Now, in the next video, we're going to take it a step further and do molecular formula. Remember, this is a reduced formula. You can't reduce this anymore. 5, 7, and 1 cannot be reduced anymore. So how do we get a molecular formula? That's going to be part 3. Okay? All of this is going to tie together. We will do some in class, so don't stress. Just make sure you have your notes and all of the examples, okay? We will have a quiz over the notes at some point, okay? So just be aware. All right, see you guys in the next video.